So looking at this question that comes from the 2022 mock examination, the image on the right shows a sunroom of a residential house. It is composed of a series of planar glass surfaces. Figure B-3 shows the plan elevation of the intersecting planes A, B and C. The questions that go with this: draw the given plan and elevation of the intersecting planes A, B and C. Determine the dihedral angle between the planes B and C. Determine the vertical and horizontal traces of the surface C. And find the true angle between the vertical and horizontal traces of surface C. Scale is 1:1, so there's no need to change the measurements. So for part A, we're given our elevation and we're also given the plan. We have our heights and elevation of 10, 10 and 25 for a total height of 45. And in plan, the back here, which is the top of roof surface B, is a width of 20 or a length of 20. Front part of B has a length of 50, and from the edge of A to the edge of C, 90, and the overall width is 60. So with great care and attention, draw the elevation and draw the plan, and that completes part A of the question. So once you've set up your elevation and your plan, that completes part A of the question. Part B then asks us to get the dihedral angle, the true angle between surface B and surface C. So the first thing to do here is we have to look at the line of intersection, because the first stage of this question is to get the true length of this line. If you look at the line there in elevation, we can see it's sloping down there. So it is not, as we look down in plan, we are not looking at it at an angle of 90 degrees, and therefore we do not see its true length. So we need to get the true length of this. Now, if you look along the true length of a line on a plane, the plane will project as an edge. So because this line is common to B and common to C, if we get the true length of this line and then look along that line, B will project as an edge, as will C, and therefore we will get the dihedral angle, because we'll be seeing both planes as edges, and this is how this method works. So for the line 1, 2 is the line of intersection, so we project off that at an angle of 90 degrees from the plan. 3 is another point on C, so we bring that up. And although B has 4 points altogether, this point, this point, this one and this one, we only need 3 points on surface B. So I've picked this point here, 4. I've drawn a line from 1 to 4 and back and 2, and then all of those points go up here. Now, moving up here into the elevation, we have 3 has a height of 10, 4 and 2 have a height of 20, and then 1 is 25 millimeters higher than that, for an overall height of 45 off the XY line. So when we go up here to our auxiliary view, we have our projections coming here from the plan. We set up the X1, Y1 line, and then we mark our heights: 10 up to 3, 20 up to 4 and 2, and then from here 45 in total up to number 1. Join the points as they are in plan, so you have a line going from 1 to 2 to 3 and back to 1, 1 to 2 to 3 and back to 1, and then on the other side we have 1, 2 already, and then from 2 to 4 and back to 1, 2, 4 and back to 1, and that then completes the auxiliary elevation. So this is the auxiliary elevation, and it shows us the true length of the line 1, 2, which is the line of intersection. So then to get the dihedral angle, we extend on 1, 2, and we bring 4 and 3 up here parallel to it. You establish your baseline, your X2, Y2 line, and because this is an auxiliary elevation, when we project from that, we get an auxiliary plan. We have to take our distances back into plan. We go down here, and again, you could use the x1, y1 and take this back, but you have a huge amount of distance here that you don't need. So we put a baseline going through 3 that is again parallel to 1, 2. So because this baseline here is parallel to 1, 2, the distance from the baseline to 1 and 2 is the same, and then we have the distance there to 4. So 3 is going to be on the baseline. We take the distance back to 2 and 1, which will be the same, and the distance from the baseline back to 4, and that's what we mark over here. 3 is on the baseline, the distance from the baseline back to 1 and 2 is the same, and then the distance back there to 4, and we connect them up together, and that gives us the auxiliary plan, and you see the dihedral angle, the true angle between surface B and C. That completes part B of the question. After part B is complete, the next thing that we're asked to do is to determine the traces, the vertical trace and the horizontal trace. These are the lines that are formed when a plane intersects the horizontal plane and where it intersects the vertical plane. So, looking at this here, we are asked to get the traces of the plane that contains roof surface C. This is roof surface C here. So where are the traces going to be? They're going to be on the horizontal plane, and in elevation the XY line is an edge view of the horizontal plane. So we extend down the line 1, 2 until it intersects the horizontal plane here, and I extend on the line 1, 3 until it intersects the horizontal plane here. Now, those are the 2 points in elevation where this plane intersects the horizontal plane. Where are those points going to be in plan? Directly below it. So both of those points now, we bring them back down into plan. So the points we're looking for are on those lines somewhere. The exact point then, what did we do in elevation? We extended on 1, 2, and we extended on 1, 3. So we do that in plan. Extend on the line 1, 2, until it hits the line coming from that point there in elevation. Where the 2 of them cross, give you a point on the horizontal trace in plan. And likewise with 1, 3, extend it on, and you can see that's where that line is intersecting the horizontal plane, so that's going to give us a point on the horizontal trace in plan. And once we have 2 points on the horizontal trace, that point there and that point there, line up your set square with both of those points and join the horizontal trace into the XY line. To get the vertical trace, we can do a similar thing in reverse, but this time extend the line 1, 2 back until in plan until it hits the XY line, because the XY line in plan is an edge view of the vertical plane, so that's where it's intersecting the vertical plane there. Where it hits the vertical plane, bring it up and extend 1, 2 on to meet it. Where the 2 lines cross, give you a point on the vertical trace. Both traces have to meet at the XY line, so from here where the horizontal trace intersects, draw a line through there, there's the vertical trace. So there's the horizontal and vertical trace found. That completes part C. Another way of getting the vertical trace would be any line on a plane that is parallel to the horizontal trace is a horizontal line. So if I draw a line from 2 parallel to the horizontal trace, that's a horizontal line all the way into the vertical plane. Everything on that line will be the same height. So you can see there you have the height of 2 in elevation. Bring that across because it is a horizontal line. Because this line here is parallel to the horizontal trace, it's a horizontal line in elevation. That's where it hits the vertical plane, so that's where the vertical trace is going to be. Bring it up and both lines cut there on the vertical trace. That's another method of finding a point on the vertical trace. Bringing a line parallel to the horizontal trace in plan and a horizontal line in elevation, and where the 2 lines intersect, give you a point on the vertical trace. So 2 methods there of establishing the vertical trace. And finally, part D, which asks us to determine the true angle between the vertical trace and the horizontal trace. So we want to find the true angle between the two traces. Now this is done by rebatment. So the first thing we have to do is we have to get an edge view of this plane. So we extend on the horizontal trace, set a baseline up across that. We need a known height now on the plane. So here's our height line there in elevation, but that would be the plan of that, because this line is drawn on the vertical plane, because that gives us our point on the vertical trace, which we need over here because we need to draw the vertical trace on the flat. So there's the height line. You bring that up parallel to the horizontal trace. Again, this is an auxiliary elevation, so we take our height here from this elevation and mark it up here. And there's an edge view of the plane that contains C. That point there is on the vertical trace, because we can see that there. That point there, because it's on the vertical plane in plan, that point there is on the vertical trace. So what we do now is we put the point of our compass there, and opening the compass from this point to here, we rotate that onto the horizontal plane. So we're literally getting the plane and now flipping it over that it is resting on the horizontal plane. Bring that back again parallel to the horizontal trace, and then this point as it's flipped over, and again that is a point on the vertical trace, comes across there, cuts across the horizontal trace at 90 degrees, and then gives us this point here. So that there is a point on the vertical trace. So we draw our line from here through there. And what we have now is we have the vertical trace now lying flat on the horizontal plane. That's the whole idea of this, that we have the vertical trace lying flat on the horizontal plane. And when you have that there, you have now the true angle between the vertical trace and the horizontal trace. And that completes part D of the question. So that there are all parts of the question completed. Part A, setting up the elevation and plan, which is straightforward enough. Part B, determining the dihedral angle by coming off the line of intersection at 90 degrees, getting its true length and then getting a point view of that. Part C, determining the traces by extending on these lines 1, 2 and 1, 3 until they hit the horizontal plane, and then bringing them down into plan here and extending them onto these lines and getting the horizontal trace, and then determining the vertical trace. And then finally part D, getting the true angle here between the traces. I hope this video has proved informative. Thank you for your attention.